So, last but certainly not least, Dr. Peter Leavitt is here from the University of Regina, as I mentioned before. Dr. Leavitt has a very busy schedule, and so we are very appreciative of him taking time out to be out here with us this evening. So, welcome, Dr. Leavitt.
Thanks very much for coming in, folks. What I'm going to do is I'm going to tell you a couple of stories and then raise 3 issues that, irrespective of the type of mine or the precise proponent of the mine, that would be worth considering. I'll give you some thoughts on what I think might be relevant. First, I just want to talk a little bit about why me? Why am I being asked to speak on this? And I moved to the province in 1993, and the following year I started working on the lakes and the rivers of the Qu'Appelle system, but also generically freshwater resources in Canada. The work that we do is at the interface between societal development and environmental concerns. So I'm interested in climate change. I'm interested in how we might do it, but what it'll do to us. I'm interested in farming activities. What can we do to increase productivity, but what in increasing productivity might that do to the environment? My focus is on water. And the 2 main themes that we work on right now are climate variability, and human activities. And in each of those categories, there's 2 basic things we do. We go back in the past using fossil records to tell us what it was like historically, so we have some basis for understanding what it's like now. And then we do experiments and studies in the modern world to try and understand what's going on at this moment. And then you take the 2 of them together, where we were, where we are now, and you can make some sort of a forecast of where we might be in the future. So that's sort of how things are organized in my head. The research that we do is, as I say, mainly dealing with freshwater resources. Fortunately, that's not a picture from Saskatchewan, that's from Madison, Wisconsin. But we do long-term monitoring. So we just go out to the lake every other week and we see what it's like. How green is it? Or is the water clear? What's growing in it? How is it growing? Is it changing through time? And it gives us a baseline to understand what our effects might be and what the natural change in the environment might do. We also reconstruct the past to, again, provide a longer time frame. We all think, oh my goodness, 2011 was pretty wet, and 97, 98, well, that was dry, and we'll maybe have a dry winter this year. But is it really dry relative to what it might be over 100 years or 200 years? Some of these mines have lifespans well into the decades, if not a century, and you've heard we've got half the potash on the planet. We need that for growing food, and there's going to be more people in the future than there are now, so I'm pretty damn certain we're going to need more potash in the future. So this is an issue, whether the market's soft now or hard firms up at all, doesn't matter. We're going to be dealing with this for some time, so we might as well take the time to think about it. So this is a satellite view of where we live. We're sort of in the middle there. Mainly my concern, a lot of the research that we do at the University of Regina is in the Qu'Appelle river system. And we study this system because it's a good model for a lot of places on the planet that don't have that much water. When you've got lots of water, it's easy to be cavalier about it and not really care, there's another lake, this one dies, it doesn't matter. It's more serious when 4 or 5% of your surface is water, and that some of it's far too salty to be used. The lakes that we've been working on, I don't have Pasqua Lake on here, but Pasqua is another of our study sites, pretty much run the full range from the source water in Diefenbaker, which is not the natural source to the Qu'Appelle, but is conveyed water. It's also the conveyed water for the mining that we're going to talk about today, so I'll come back to this in a second. Wascan is in the city of Regina, Last Mountain Lake, you should know, Long Lake, and then one's down towards Manitoba as well as Buffalo Pound. Doesn't matter what's up here. The main thing is we look at the biology of the system, we look at the chemistry of the system, we look at the physical properties of the system, and try and understand how they interact. And any kind of resource development will affect all 3 of these things. Some of them you might care about, usually the biology. Some of them you won't care about unless there's a health consequence, the chemistry. And some, the physics, you probably will never care about unless it's too warm or something like that. We've been going out for 2 weeks, as I say, mostly during the summer. This is a project that's driven by federal and provincial funding, but there's a lot of student training involved. The students are available in the summer. Nobody wants to sample in the winter, so there you go. We have a monstrous research craft, as you can see here. It's actually great. The real reason for doing it is we don't have to drag it behind a truck and flip it over on the highway and then spend a lot of time paying insurance bills. But we have a lot of fun going out. The students go out and they do a lot of the collections in the creeks and in the rivers. Hope she doesn't get any deeper. Those chest waders are just about full. And as I say, this is a high-speed photograph of me. I know it's high-speed because it's a picture of me in the field doing work, and you need very good film for that. One of the things we do is we take tubes of mud out of the bottom of the lake, and we let the history of the lake reveal itself by looking at the little pieces. What's at the top of the mud was stuff that died and sank to the bottom yesterday, and then you go deeper and deeper and deeper and deeper. It's like flipping through the pages of a book. You go back in time, and by looking at who used to live in the lake, you can get a sense of what the lake was like in the past. There's a little thing that used to live in the lake. It's a little single-cell plant. It's called a diatom. Its cell wall is made out of glass. You can see little lines in it, and that tells us what the species is. And there's hundreds of these things in most lakes. And we can use those to reconstruct the history of droughts in central Saskatchewan. That's what that is. It's a 2,000-year record of how salty Humboldt Lake has been as a result of climate variability. It's been everything from the salinity of the ocean practically to the most drinkable fresh water. And so getting some perspective on what's normal, what's average, gives you some idea of what we might do in the future. So I'm going to tell you 3 stories. I'm going to tell you a little bit about the pollution of Pascal Lake, and this will seem off topic now, but I assure you we'll round back to it when we talk about potential mine effects. I'm going to tell you a little bit about climate change because it is occurring. It always occurs. The climate isn't stable. But it does impact, I think, what might happen in the future. And the thing about mines is any one mine probably is not going to damage the environment that much unless it's badly managed. It's simply true. But we're not talking about one mine. We're not talking about one mine in the isolation of everything else. There is climate warming occurring. You can debate, if you like, why it's occurring, but it's measurably getting warmer. What does that mean, and how might that interact with farming? And how might that interact with the city, and how might that interact with the mines? And this is, unfortunately, how complicated it is. So then, the one you're probably most interested in, I'm going to talk about 3 main things, potential impacts of potash mines generically, but I'm going to talk mainly about the proponents of mine for the Saudi area. So we'll start with Pascal Lake. We've been looking at the effects of the city on the downstream water quality for about 23 years now. And I'm just going to skip through this quickly. The reason I care is because the city of Regina is very peculiar. It's a comparatively large city on a very, very small body of water, Wascana Creek, which probably wouldn't run most of the year if it weren't for the water being pumped out of Buffalo Pound into the city through the water processing and then back down into the creek. But it's a pipe, and the pipe only goes one direction, and that's into Pascal Lake. And so we're curious about what the effects of the city might be, because the water quality, as many of you will know in Pascal Lake, is not particularly good. It's prone to these surface scums. You can see some of them near the writing down there. And the scums have impacts on livestock. They have impacts on our pets. We are probably not that threatened health-wise by these things. But it just basically means the lake isn't that attractive to use. The city's done a pretty good job generically about improving water quality by reducing nutrients, and there's 2 lines there, a blue line with an N meaning nitrogen from the city and a red line with P meaning phosphorus. It's 2 fertilizers. Any of the farm would be familiar with this. The city's removed most of the excess phosphorus from its wastes, and you'd think the system would get better because many people think water quality is affected by the input of these nutrients. Turns out that's not true. Pascal Lake, for example, in comparison to Buffalo Pound, is getting more and more urban pollution through time, particularly with nitrogen. This nitrogen, which is indicated there, makes the water greener, and many of the things that grow in the lake float on the surface. So not only is it greener, but it's all concentrated right at the surface. So what you're looking at is almost, tens of feet of plant life all jammed up into the surface, and it looks like hell, to be honest. So as a result of this, some of these things are not particularly good in terms of water use. I've got there the Canadian drinking water maximum and the recreational maximum, that's the don't touch part. And this is for Pasqua Lake for a couple of years back, where we just monitored the production of waterborne toxins by the algae, the green stuff growing in the lake, and every now and then it crests above the don't touch area, which is not what you want to see. And this is driven because of the input of nutrients, principally, though not exclusively, from the city. We've done experiments where we take that nutrient, we dump it into the lake and see what happens. And you grow more algae, it gets greener, and they get more toxic. So as a result of this, at least in part, as well as changes in the federal regulation, the city decided to upgrade its wastewater plant. That's going to kick into effect in 2017, all else being equal. Now this is important for trying to evaluate the effects of mining, because the recovery of the lake from urban pollution, from the city's input of nutrients, will probably take decades. So it will be ongoing at the same time you're trying to evaluate whether there's any effect of mining. And this is why I suggest that we need to think of things in a cumulative or integrated sense. Some points there, that the main thing is that Pasqua Lake is polluted with nitrogen, and there's about a factor of 500% more greenness now than there would be historically. And it's mainly driven by inputs of nutrients from the city. The city has taken steps now to resolve this issue, but you can expect the recovery is going to be prolonged sufficiently that it's going to interact with climate change, and it's going to interact with mining concerns. So let's talk about climate change a little bit. Again, so these are the system that we're working in. We're looking at about 50,000 square kilometers. There's 6 lakes in the central core that we study all the time that aren't receiving direct inputs of pollutant from the city. I don't include Pasqua Lake for this because it's hard to separate climate effects from the effects of the city sometimes. And there's climate stations that we can use to compare the measured change in rain and snow and the changes in the temperatures with what's going on in the lake at the same time. And the sorts of things you might be interested in as well: how green is the water? Is it really scummy or is it clear? So the water clarity, and unfortunately that's Buffalo Pound during one of the particularly bad blooms of algae where all the stuff is floating to the surface. And we've lowered a disc that's about 8 inches across, and it's in black and white quadrants, and it's down a whole 5 centimeters. It's down about that much, and you can't see it. So there's quite a bit of algae in the lake, and that affects how the water's processed, and that affects whether you can use the water. So problems we've had with the city of Regina and water availability, there's water, it's just it can't be processed as fast as we need it, as fast as the demand is. And then we might be concerned about whether there's species that we don't want to see, toxic species. Maybe they just cause a swimmer's itch. Maybe it's more serious than that. And these are things that we're trying to understand: what controls, whether it's green, whether it's clear, are there toxins, or is the water good to go? There's a lot of things that affect water quality. Climate systems, like you heard about El Nino, that's one of the things that can have an effect. Just the weather, which is the sort of the local manifestation of these big climate things, like is it wet today, is it dry, is it hot, is it cold, that sort of thing. What we do on the water, in the water, with the water, this potentially has an effect, as does the amount of water and how we move it around the environment. Most of the southern Saskatchewan water bodies are pretty heavily regulated. The Qu'Appelle certainly for many, many decades has been managed to reduce flooding, to try and increase predictive availability of water. And so this, believe it or not, is 20 years of my life. Doesn't look very interesting. It isn't, but move past that. So you can, maybe I've just made it simple. The top stuff is the 6 lakes we look at and how they've changed over 20 years in terms of greenness, in terms of how clear they are, and the scumminess, whether it's sitting on the surface where you don't want it. There's not really a simple trend. It's not getting obviously worse. It's not getting obviously better. There's some noise in there, and we try and understand why it's as noisy as it is. There are pretty evident differences among lakes. Some lakes, like Diefenbaker, are always clearer than other lakes like Wascana or Pasqua Lake. And there is some evidence of cycles, things that might be predictive, that might be useful for understanding, why it's going to be a particularly bad year. And El Nino seems to pop out as one of the ones that we are seeing as important. I want you to get almost nothing out of this except that each of those pie charts has a lot of colors in it. Each color is something that affects water quality. So my point is, whether you're looking at the total greenness, the total algae, how clear the water is, whether it's the surface scum, or whether it's those toxic species,
they've all got a bunch of slices, meaning there's no one thing that I can say, if you do this, it's going to fix it that way. There's a bunch of controls here, and that's the piece that I really need you to keep in mind, that there are lots of the ways of improving or degrading the surface waters in the province. Very simply, if we worry about how much water is moving through, and that might be related to a drought, it might be related to conveyance for mining, the main effects that we're seeing in the Qu'Appelle are on how clear the water is and what the total amount of algae is. The amount of water going through the system doesn't seem to affect the toxicity, doesn't seem to affect the surface blooms, whether it's on the well mixed or floating on the top. Temperature's a big deal. The warmer it is, the worse pretty much everything gets. And nutrients have a big effect, particularly on the total greenness of the water and the presence of whether it's floating on the surface or not. As it gets warmer, we're going to have more scum in the lakes. So the forecast for the temperature increase in the prairies is about 4 degrees or more in the next 50 years. Based on our analysis, we'll have twice as green lakes as we had historically. Why? Because when you look back in the past and you look at how variable the temperature is, this is the relationship you see. Just a nice step increase. It gets warmer, it gets greener. As you might suspect, if you get rid of nutrients on the right-hand side from the dashed line, you get less algae. If you get more nutrients, you get more algae. It's not terribly surprising, but it's a little bit less important than the temperature. And then here is basically the changes in river flow. If you get more flow in, you tend to get less algae, and if you get less flow in, you tend to get more algae. But the thing that's really important here is that bottom piece. To say double the clarity of the lake, you'd have to put in 10 times more water, which is basically not possible from an engineering perspective. So there's not much that's going to happen from the direct flow of water in through most of the systems if you don't do anything other than put more water or less water in. But if it gets warmer, or you put more nutrients in, you can expect worse water quality. That's more or less what that says here, and I won't belabor it. So let's get to the potash issues. We've heard already, it's not a mine, it's a whole bunch of mining concerns, and this is now already badly out of date. I prepared it when there was concern about the development near Chrono. Some just numbers, each mine uses an awful lot of water. So 21 million cubic meters of water. It's a little hard to picture that. I was looking at the size of this room. It's maybe 20,000 cubic meters in this room. It's 21 million cubic meters per mine. There's several mines that could be developed, and I think we can reasonably expect all these mines to come online in eventuality. It's unlikely the market's going to stay soft in perpetuity, that it's going to be low commodities prices. So as the commodity recovers, there'll be interest. Why? Because we have half the potash on the planet, and it's in a relatively accessible form. What that means, though, is the draw on the available surface water, fresh surface water, is going to be pretty high. Really, there's just the one river running from west to east. South Saskatchewan obviously does as well, but it's getting progressively further to the north from here, so it's not clear that it's going to be a good source. There's concern about, therefore, the source of the water and how moving that water around might affect things. And so the three things I'm going to finish up talking about are whether the ultimate source of water for mining, which is Lake Diefenbaker, the South Saskatchewan River, is a reliable source or not. That's very far away, and we're not planning, at least that I'm aware of, we being the province, piping the water from Lake Diefenbaker. We're going to run it through the existing means of conveyance that is down to Buffalo Pound, and it's going to be piped from Buffalo Pound, where it's already piped to the K+S, or will be, to Mosaic, and to the cities of Moose Jaw and Regina. So what are the effects of moving more water through the lake? Is it good? Is it bad? Do we know? And then finally, I want to talk a little bit of effects of waste salt. We've talked about potash as if it were sort of existing in isolation, but Corey had a nice little presentation that there's different types of salt, and potash is a salt. Some of it's better for the environment than others. And so what are the potential issues there? So this is our main source water. This is Lake Diefenbaker, and the water from Lake Diefenbaker comes from there. It comes from the east-faced snowpack of the Rockies. When the snow melts it gets into the Bow and several other tributary rivers and comes down the South Saskatchewan, where we dam it and use it as a reliable water source. It's dry here, right? There's no trees on the prairies, right? There's not enough water for them. So the reliability of the water in Lake Diefenbaker depends entirely on the reliability of the snowpack, or to a large extent, as well as industrial and commercial and domestic extraction in Alberta. The supply of water in Lake Diefenbaker has been dropping irregularly but progressively for about 100 years. It's down about 30%. And this is corrected for industrial extraction. This is what's called a naturalized flow, and this is the work, well, David Sachin provided this, but this is the Prairie Province's Water Board has more information on this. Lots of up and down, keep that in mind. Lots of up and down, but generally speaking, an overall downward trend. Dr. Sachin at the university's Prairie Adaptation Research Collaborative, or PARC, has done a reconstruction of the water level in the South Saskatchewan back over 1,000 years. And I won't go into all the detail, other than you need water to grow trees, and so you can use the growth of the trees to tell you how much water they had in the past, and therefore what the water availability was. So there's the dirty 30s there, that little red bar, and let's just say that's important. That's a level of water availability that we have some concerns about. Why 20 to 25% of the people left the prairies? Because it was too dry to farm. After 6 out of 7 years drier than average, people moved into urban centers. It still didn't get any better, they just left. If we use that as a critical shortage, you can see that that blue line, which estimates how much water was in the river, is well below critical on a number of occasions. It tends to have been worse in the past, but there's a regular incidence of the water level not being up to expectation in the South Saskatchewan River. Can you do anything about it? No. You can dam the water, you can store it as much as you want, but if it's not coming in, then there's nothing you can do about it. And so, as water sources go, this is really pretty reliable. It's better than looking at Last Mountain Lake, in my estimation. It's certainly better than looking at the downstream lakes, the Qu'Appelle Lake. Even the Quill Lakes, which are now quite full, weren't historically full. You can reconstruct the lake level in these lakes, and you can see that the 20th century has been one of the wettest centuries of the last 2,000 years. Almost every other period has been a little bit drier than it is now. So yeah, it's a reliable water source, but the variation, the change through time, is part of the natural system. Humans didn't do it, it's just stuff happens. So let's talk a little bit about the effects on Buffalo Pound. There's a lot of water moving through a narrow, long lake. You might be concerned about whether there was an effect of putting water in and then extracting it out for the mines and extracting it out for the cities. And it's very difficult to know, since we haven't been measuring as we go along. So the way we've chosen to do this is we're going to go back in time to the mid-20th century, and we're going to reconstruct how green the water was from what the fossils in the mud. So from Buffalo Pound, which gets conveyance, and Pelican Lake, which doesn't have conveyance, by comparing the two, they're roughly the same land use, roughly the same climate. The main difference is whether they're getting engineered water through them. So we compare them to see if there's an effect of the engineering. We take a core of mud, we extract a bunch of things out of it. The greenness of the lake can be shown at the top there by the color of the sediments. There's little fossils of things that used to work in the lake. Almost everything that lives in the lake dies in the lake, and it sinks down to the bottom. You can see some piece of it in the sediment to tell you whether it was something you like or something you don't like. And then there's a bunch of chemical analyses we can do that tell us a little bit more about where things came from. Now, this is a data slide, and I know you probably don't want to see this, so I'm just going to skip to the punchline. You can see in Pelican Lake, things got bad about 1960 and just kind of went up to a peak and then sort of fluttered around from there. Whereas in Buffalo Pound, things didn't really get bad until after the 1990s. The water quality is degrading in Buffalo Pound, but it doesn't appear to be related to the conveyance. In fact, our estimation is the water quality is a little bit better than it would be if the water wasn't being brought into the lake for mining and urban extraction. It's just the way it is. It's not what I expected, but what it suggests to us is the lake would have been greener, it would have had more problems with toxic algae than it does, but seemingly for the fact that water's coming through. So this is an interesting result, not one that I would say I expected, but it's one that we found. To finish up, we'll talk a little bit about the effects of waste salts If you've never seen the pile, it's a big pile. You get approximately 2 to 1 tons of waste salt or halite, table salt if you want, to potash or potassium-bearing salts on average for your mining. So the mine, for example, Mosaic, produces a pile that's about 1 kilometer by 1 kilometer, but about 300 feet high. It's a big pile of salt. It's windy on the prairies. And if you ever sneezed when you're salting your sandwich, you might have noticed the salt just doesn't stay there when it gets a little bit of wind. And well, this is true for potash concerns as well. Mosaic is a good model. As pointed out, we were leading the world in terms of solute mines. It's the world's oldest potash solute mine. So we can look and see what it might look like around here in 40 or 50 years' time by just looking at how it's changed around there over the course of the same period. So here's 2002. This is a Google image. You can see there's a lot of water, standing water inside and outside. And I don't want you to take too much out of this, only to point out that if you look at the same site in a more dry year, there seems to be evidence of salt deposits as far as 5 kilometers away, and predominantly in the downwind direction. Now, that's not proving that that's salt from the pile. There's other things that could be happening, but it is consistent with it. The other thing it's consistent with is the drift of salt off of sloughs and salt lakes, like Old Wives Lake. You can see a similar salt band to the south and predominantly to the east as a result of this. And in the case of the Salt Lake, there's no ambiguity about where the salt came from. Now, we think chemically you can probably tell if this salt is derived from the mine. As it was pointed out, this was an old ocean bed. The chemical signature of the ocean is different from the chemical signature around us now, and so it's possible we could actually say whether this was or was not salt from the mining activity, which would give us a way of determining whether any given mine was polluting the environment with salt or not. The reason we care, again, is not exactly one mine at a time. It's the potential interactions between mines and other activities. So my concern historically was that there was a couple of proposals in around Regina, which is in the headwaters for Wascana Creek. In fact, most of the surface area of Wascana Creek was within this spray zone, and so there was real concern of how would you possibly keep the salt out of this creek. And the reason for the Yancoal thing, there is some suggestion that Loon Creek is maybe far enough away, but it will depend enormously on the siting of the waste pile relative to the creek, and also whether there's any change in the flow of the water as a result of subsidence. Here's the kicker. Salt is great on your sandwich. It's not great in the water. It's toxic, and there's a lot of research on the effects of salt. Now, this is the picture of the effects of salt on the lake. I just needed a dramatic photo, and so there it is. The thing that probably more important for us is we have some species that provincially are considered threatened. Bigmouth buffalo, not a particularly attractive fish, I will say, but it breeds in this area, and it does well in areas that flood intermittently. And I couldn't say that it was in Loon Creek, but I also couldn't say that it wasn't. The ministry would have to investigate that. But these taxa, generally speaking, do not like exposure to salt. And so if the salt stays in the pile where it's supposed to at the mine, no problem. If it doesn't, potential problem. This is a little hard to explain, but there is a weird effect of the salt. If the salt were to get into Loon Creek, it would go downstream and end up in Pasqua Lake. And on the top part of that is just a map showing how deep the lake is in meters. So you multiply by 3 if you want to get that into feet. It's basically very shallow on the west end. It gets progressively deeper. And I've done a little cartoon there showing a cross section through the lake. Now, the reason it's important to keep the salt water out of the lake is because salt water is heavy. It's dense, it sinks. So when you put it in a lake, it follows the bottom of the lake until it gets to the lowest point, and then it just stays there. And it fills up. Now, that has 2 effects, one of which was probably you'd think of as bad, and one of which you might actually think of as, oh, that's not so bad. The bad one is that water in yellow there tends to be isolated. It never, ever, ever mixes to the surface. And so it is incapable of supporting fish, and generally speaking cannot support invertebrates. The water is so dense that it just can't float up any further. However, that same sort of water can also act as a nutrient trap, and Pasqua Lake is right now the recipient of almost all the waste nutrients from the city of Regina. So the presence of the salt actually could make the water quality recover a little bit faster in Pasco Lake. I'm sort of guessing here, but I would say that it's worth, I'm not saying put salt in it by any stretch. I'm just saying that it's never as simple as this is a bad thing, this is a good thing. It's all nice and black and white. It's good, there's lots of shades of gray here. Ooh, bad reference, but you know what I mean. So to finish up then, you know, Diefenbaker, in my estimation, is a good, reliable source of water, but it's not bulletproof. We live in a dry climate, the climate is changing, and it's getting drier as we go forward. We see evidence that most of the lakes in the Qu'Appelle are pretty easily degraded. Some of it we can't control, the changes in temperature. Other nutrient inputs we absolutely can control. And it's pretty clear that the water quality in Buffalo Pound is degrading. I suspect this is more a regional thing relating to the temperatures getting warmer and warmer. And then to me, one of the critical issues is going to be this waste salt, the sodium chloride. How well can it be constrained on the landscape? Can it be prevented in getting, and we're not talking about occasionally getting it, just keep it out of the surface waters if we can, and what can be done there. I know there are engineering solutions to this. I am not particularly aware of how effective they are, but these would be the things that I would be thinking about as this mine goes forward. Thanks very much.